In this lesson, we're going to do three things. First, you're going to learn how to graph a single inequality. Then you're going to learn how to graph compound inequalities, both of these on the number line. Then we're going to solve them. So let's start with this. Throwing back some old elementary school stuff. You need to remember what the symbols mean. So less than is pointing to the left. Okay, it always points at the smaller piece. So less than goes that way. Less than or equal to has the bar underneath it. The bar underneath the symbol means it can be that number. It can be less than that number or that number. Okay, different color. Greater than is going that way. And greater than or equal to, same concept. Okay. There are all kinds of little tricks. One thing I use is I say the symbol is always pointing at the smaller number. People say the alligator's mouth is going for the bigger one. Whatever works for you. Now on the number line, a closed circle is what you used, say, for a greater than or equal to and less than or equal to. So the number can be part of the answer. An open circle means it's almost there, but it's not part of the answer. Alrighty? Now I'm going to try to match the colors. Let's look at the first one. A is greater than or equal to 7. I'm reading it from left to right, and I'm reading what the symbol means. A is greater than or equal to 7. So A can be, I'll put it in quotes, be 7, 8, 129. Alrighty? So my recommendation to you is do this above the number line so you can keep track of things. I'm going to find 7. I'm going to draw a circle and color it in. It's a closed circle because A can be 7. And I'm going to draw a line going to the right because A can be 7 or any number greater than 7. Now, let's look at the next one. The next equality. Again, I'm reading left to right. X is less than negative 3. So X cannot be negative 3. There's no bar underneath. But it's less than. So I draw a circle and less than. With negative numbers, the bigger the number, the less it is. So that's why the number line, when you get into negative numbers, the number line goes to the left as the numbers grow. All right, so this is the inequality. X is less than negative 3. Open circle, because X cannot be negative 3. Now, compound inequalities. And statements and or statements. An and statement means the number is between here and here. Line is between points. An or statement, there is a gap. Okay, and another way to say it, an and statement, line connects, lines are connected. An or statement, lines are apart. Two different ways to view this, but they're saying the same thing. Let's graph this compound inequality. And I'm going to do a completely different color for this one. You got X is greater than 5 and X is less than negative 3. X is greater than negative 5 and less than negative 3. So let's do this. X is greater than negative 5. Open circle, and it heads that way because X is greater than. The next one, X is less than negative 3. open circle, and that heads that way. That's interesting. You know what makes it look really, really nice? I'll do it down here. Now I just connect the two. So this way you can see, this is the really good answer. That way you can see that the and statement is true. X is between -5 and -3. It is greater than -5, but smaller than -3. So the lines go together. Now we're going to graph the next one, which is an or statement. Okay, open circle again because there's no line underneath. X is less than -8, or X is greater than 4. So this is the or statement. The lines go in different directions. That's the difference between an and statement and an or statement. Now in this part, we're going to show you how to solve the problem. I'm not going to make you graph it, but you can later. So right now it's how to solve it. I'm going to ask my favorite question. Does the algebra change? No. The algebra process does not change. You are still going to get the variable by itself. You're still going to move things by undoing them, doing opposite operations. I'm going to draw my t. Same process we did when we were adding and subtracting. The v is already on the right. I'm going to do the opposite of -3. I'm going to add 3 to both sides. Again, algebra's balance. So I have 23 is greater than or equal to v. Now, when I look at the tests, students can do the math, but what they forget to do is they forget to write the inequality. They simply write an equal sign. You need to keep track of your inequalities. You don't want to lose points for something silly. So make sure you carry your inequality down. Let's do the next one. Draw my t. The v is over on the right. I'm going to leave it on the right. I'm not going to move it. But I am going to add 19 because that's the opposite. Add 19. Remember how I would cancel them out? Because it's 0. So I have 37 is greater than v. That's it. That's all you do. Again, we're not graphing. Now, let's put some fun in here. There is a rule, here's my t, that says when you multiply or divide an inequality by a negative number, you flip the sign. So let's look at this. You've got -3 times u is greater than -12. You want 1u, so you are going to divide by -3, which you did the first day we learned this material. Whoops, divide by. There we go, for my sign. That gives you u, and -12 divided by -3 is +4. But you have to flip the sign. So u is now less than 4. Big circle around this. U is less than 4 because I divided by a negative number. Let that sink in. I divided both sides by -3, therefore the sign, the inequality sign, flips. Let's do number 4. Another t. What do I need to do to get the d by itself? Right, I have to divide by 5. Divide by 5 both sides. So I have -9 is less than d. Do you notice that sign did not flip, even though there's a negative number on the around there? That's because I divided by +5. So the sign did not flip. In problem number 3, I divided by -3. The sign flips, the inequality symbol flips. In number 4, I divided by +5. The inequality sign does not flip. Now we're going to do the same thing on number 5. Pay attention to the signs. V is being divided by U, so therefore we are going to multiply. Remember, I did the circle. Multiply the denominator by the number on the other side, and you get V is greater than 8. Same thing over here. Circle the 4, multiply it by 3. 12 is less than or equal to C. And that is solving one-step inequalities. The exact same algebra you did at the beginning of the unit. We just have a different symbol. Instead of an equal sign, we have an inequality symbol, but the algebra process stays the same.